हाँ ना।
Hello? Okay. Uh, Hello? Am I audible right now?
Hello. Hi, yes.
Hello?
Yeah, you have any question? Yes.
Yes, you are.
The volume is very low.
Okay. Am I audible?
Sir, your volume is quite low. Your audio is quite low in volume.
Yes, sir, you are audible.
Okay. Okay, fine. So in today's session, we'll be discussing
Hello.
about the
Hello. I am audible, bro.
yeah. Okay, so please mute. Okay. So in today's session, we'll be discussing about a few questions, and if you have any doubt from any week, you can ask. Okay. So we already taken many sessions for the revision purpose. So
Sir, hello, sir.
yes.
Sir, can
Yes.
you, please discuss the week 9 to 11 theoretical portion? Because it was not discussed in the last session, actually.
Week 9 to 11. Okay.
The important commands and the problem solving tactics.
Yeah. So mostly week 9 to 11 is basically based on the graphs and the regression part. So these are the two important topics from
Yes.
week 9 to 11. So other than this, let me check just a second. Right. It's introduction to the graph structure. Okay.
Hi, Pius.
Hello.
Yeah.
Yeah.
Is it this session is for Microsoft PL 300 exam?
No, no, it's a city session. Okay. End-term revision session for city course.
Okay. So, okay.
Working with. Okay, we'll discuss. Okay, so we'll discuss about the graphs and we'll try to solve few questions based on that. Okay, so let me share my screen. It's mostly about the graphs. Okay, okay. Is my screen visible?
Yes, sir.
Okay. Great. So, week 9 to 11 is basically based on the graphs only and the matrix. Okay, graphs and the matrix here. So when we say we have this, let's say for example, A, B, C, D, E, here we have the nodes of this particular graph, right? And you can see this arrow, these are the edges of the graph we can see, right? So whenever you see this particular edge, right? So here I, then we have direction, then here we have J. It means what? I can go from I to J, but not J to I. Okay, so it's a directed graph we can say here. Okay, but when we don't have any directions here like that, so in that case we can go from I to J as well as J to I here. Okay, that is how we traverse the graph here. Okay, so for ours for this city code, just try to understand here. Okay, so when in different questions, whenever we say is age from I to J, we generally represent by 1 here. So if we look at the, let's say for example, this is graph G and we have adjacency matrix EM here. Okay, adjacency matrix here. Now let's say for example, we have 5 nodes, right? So A, B, C, D, E. Here also I'm saying A, B, C, D, and then here we have E like that. Okay. So in the adjacency matrix, what we are saying, so if there's age from one node to another, we will represent by 1, otherwise a 0 here. Okay. So if you look at, we start with the this one A. So this is basically the rows of the matrix. This is basically the columns of the matrix here. Okay. So you can see from A to A we cannot go, so that will be a 0. But from A to B we can go. No, because there is no direction here. That is also 0. So from A, only the node we can go is basically a C here. So from A to C is basically we have a this directed arrow here. So we can go from A to C. That is represented by 1 here. Like that. A to D we cannot go directly. A to E we cannot go directly. So here we have a 0, 0. So whenever there is age from one node to another, we generally represent by 1 in the adjacency matrix here. Okay. That is how adjacency matrix is drawn. Okay, so we have discussed this in detail in the previous sessions, right? So we'll discuss with the help of example, but just for end-term exam, just remember whenever we say there is a age from I to J, so that is basically this in particular graph. But if we look at the adjacency matrix, we represent by like this M I J. So here we have a square bracket like this. So this is equivalent to what? M then we have I, then we have j is equals to 1 here. Okay. So whenever you see this, for that particular row, for that particular column, the value will be 1 here because there is age from I to j. That is what we can say here. Okay. Now, we'll try to discuss a few questions here,
Sir,
right? So, yes.
uh, can you repeat MIJ once again?
Yeah. So this is a graph given to us, and this is basically adjacency matrix we have drawn. M is basically matrix. If you want to represent the two nodes in the matrix, how we can do that? So M, then we have row, and then we have column here, like that. Okay. So first one is row, second one is column. Now, if you just say this two node I and J, and there is arrow from I to J. So in the matrix, what we can write M in square bracket I, then in square bracket J, that is equals to 1 here. Similarly, if you look at the D and E here, so I can write like this M, then in bracket D, in bracket E, like that, that is equals to 1 here. So Dth row and E column. So D row and this E column, the value will be 1 like this. Similarly, you can see here we have A row, C column, the value is 1. So it means what? A row and C column, the value is basically equals to 1 here. So from this thing, we can get an idea from A to C. From A to C, we have an H here. You can see, not C to A. So row to column, we have an H here like that. Okay. This is the information what we can infer from the given scenario. Okay. So we'll try to
Sir,
discuss.
from table, sir,
Uh,
A to A is 0, right?
yeah. From not table, from the graph, you can see. We cannot go A to A directly here, right? So there is no a self loop here like that. Okay. So that's why A to A will be a 0 here. And from A to B, we cannot go, D we cannot go, E we cannot go, only we can go to C here. That's why we have represented by 1 here. Similarly, for B node also, from B, I can go to A. Yes, you can see the arrow, so that will be a 1. From B, I can go to B. No, there is no self loop here. So in that case, we can go for, it will be a 0. Then B to C, no, again, we cannot go directly. There is no H, that is a 0. Again, B to D, yes, you can see there is a H, so B to D will be a 1 here. Again, B to E, if there is H, no, direct H is there, that will be 0 like that. So whenever there is H in the graph, we generally represent by 1 in the matrix here. Okay. So we'll see how the question is framed based on this given concept. Anyone, any doubt in adjacency matrix? If we have given the graph, we should be able to draw the adjacency matrix here.
No, sir.
Okay. So we'll discuss.
Sir, actually,
Huh?
I have a doubt. I want to ask that in this session only, we'll be studying all the concept of 9 to 12 also.
Yeah, so we are discussing this only. And in the last session also, we have discussed week 9 to 12. In Monday session also, we have discussed week 9 to 12. Okay.
Actually, the thing was when the ma'am was taking session, I was unable to join. And after I'm seeing recording, I am getting confused.
Yeah, if you have doubt, you can ask, okay? Or you can watch the
Okay.
session on YouTube also. Previous sessions are there on the YouTube.
Okay. Okay. Thank you.
Okay.
Sir, uh,
Yes.
sir, I have one question.
Hmm.
Here, as we see that this is directed graph,
Yes.
but as we know that a click can be
Hmm.
of one node itself, right? So I just have uh, a, a curiosity on one node click. How does it look like, and in what scenarios it is applicable?
One node click. So, like
Yes,
we say click in a particular graph when that node is connected to every other node in the network, right?
yes,
So,
yes.
one node
But
click. Huh.
if it is two nodes, then I understand that the direction is from 1 to 2 and to 2 to 1. But how
Hmm.
does it happen when we only have one node click?
That's it. Only one node we have. Okay. So you can see, let's say for example, A, that's it. Okay. So here, this is basically a click only of one node, we can say.
Okay,
Okay.
so how is it click or is just a node when there is not other details given?
Yeah, it's just a node we can say. So we generally don't refer it as a click here because we don't have any edges. Simple one node is there. So in some references, it is given as this will be one click, or in some, if there is a self loop like this, one to one directly, then we can say there is a one click here. Okay.
Okay, thank you.
Yeah. But mostly when we talk about the click, so if we have this A and B, so here we have two nodes and both nodes are connected to each other. That is basically it will form a click of two node here. Okay. If I say A, B, C, so all the nodes are connected to each other like this. So this will form a click of three node here. Okay. What about the four node click? How it will look like? Is this will form a click?
No, sir. C to B and A to D as well.
Yeah. So it should be connected to every other node here.
Sir, if there is a one node, then it form click or not?
Yeah, we generally say it's a one node a click here. Okay. If one node is like that. Okay. It depends on the different scenarios, but we
Sir,
generally
so
say,
the
uh,
AB is not one node, it is two node click.
yeah, it is a two node click. Okay. So click of size two, we generally say. We can say click of size three here. Size three means we have three nodes here. Here also click of size four here. Okay. Like that. So here we have four node and every other node is connected to each other. And also one important property of click is like what we can say from this one in terms of a degree here. Yes.
Where, sir?
So what we can say from this in terms of degree here. So in a click, every node will have a same degree here. Can we say every node will have same degree? If I just consider this A, B, C here, this also 2 degree, 2 degree, 2 degree. Here also in the case of A, B, C, D, all nodes are having 3 a degree here. The total degree is basically number of incoming plus outgoing edges we can say here, right? Any question, anyone, any doubt?
No, sir.
Okay. So let's try to solve one previous term question.
Sir,
Yes.
sir, a friend or someone put a question in a chat.
Okay. Yeah. First, solve this question. We'll discuss that question also. So first, let me discuss. I have few questions. We'll discuss
Sir,
that
how
in
the fourth
detail.
one is forming a click, sir?
This one.
Yes, sir.
Yeah. So here every node is connected to each other, right? So you can see A is connected to B, C, and D as well. Here also C is connected to A, B, D as well. So every node is connected to each other. That's why we can say it will form a click of size 4 here, like that. Okay. Yeah. So first, we'll discuss the question that I have. I want to cover. Then you can ask any question if you have. Okay. So you can share the question. We'll discuss that. So first, tell me the correct option for this. If you understand the concept of a click here. Is the option A correct? There are 4 clicks of size 3
No, sir.
present in the graph.
No, sir.
So what is a size 3 a click here? How many
0
nodes?
to
Three.
Yes.
3. There are
Sir.
3.
Three clicks of size 3.
Yeah. So if you look at this will be a
0, 11, 6, and 0,
one
12,
click.
0,
This
6,
will be
12.
another click. 0, 6, 14 will be another click. Can we form any other click
No, sir.
No,
of
sir.
size?
No.
So 0, 12, and 6.
Yeah. 0, 12, and 6, 0, 11, and 6, 0, 14, and 6. It will form a 3 clicks of size 3 here. So option A is not correct. What about option number B? Node 0,
No, sir.
11,
No, sir.
6, and 12 will form a click of size 4.
No,
No,
sir.
sir.
No, sir.
11 and
We
12 are
already
not connected.
discussed. Yeah, it should be connected every other node, right? So not the size 4. Then the maximum size of click that appears in the graph is 3.
Yes,
Yes,
sir.
sir.
That
True.
is correct.
True.
Yeah. So we are just saying about the size of the click. So you can see here we have a size of the click is basically 3 here. So 3 nodes are participating. So option C is correct. What about D? Node 0 and 5 will form a
Also
click
correct.
of,
So it is
Yes,
also
sir.
correct, sir.
Yes, sir.
yeah, that is correct. Okay. So if we simply change the graph, you should be able to answer which of the following statements are correct. Okay. Uh, like that. So it graph can be anything. Based on the graph, you need to answer the question here. Okay. So this is basically concept of a click. I hope this is clear. Also in degree, out degree, right? So number of incoming edges is basically in degree. So if I have A, B, C, and a D here, okay. So if I say in degree, so basically number of incoming edges. Coming edges. Out degree is basically number of out edges, number of outgoing edges. So if I look at the example of a node B here, what's the in degree of node B?
B.
We
Two.
just
C,
have
C
two
and A.
incoming. Yeah. Out degree of node B is basically only one here because
Yeah.
one node, one edge is going outside, right? That is how the simple concept of in degree and out degree here. Okay. So click is done. Degree concept degree is done.
Sir, can you repeat the last part? The in degree out degree.
Yeah. So in degree is basically what? Number of incoming edges to that particular node. So if I just take example of this node C here, how many incoming edges we have? Only one, this one. In degree of C will be 1. Out degree will be number of outgoing edges. So for the node C, how many outgoing edges we have? Just one, that like that. So that's why in
Okay.
the for node B we have 2 in degree. So 2 edges are there incoming. So in degree will be 2. Now degree will be only 1 here, like that. Okay. Okay. So you can expect this type of question. The graph will be given to you. They will give some options based on the graph. You need to select which options are correct. Okay. Based on the
Sir, this
click, based
question
on
has
the
been
degree.
already discussed yesterday, sir.
Oh, okay. So is this all questions are discussed?
Not all this one, sir.
Yeah. In the these are basically previous term questions only. Okay. So we'll see. A graph can be different, or graph can be same code can be different. We'll see. Okay. So this is the directed graph given to us. So this is what we are saying. M is the adjacency matrix of graph G given below. Here we have Mij equals to 1. It means what? If there is age from I to J, we are saying it is equals to 1. Otherwise 0. That's it. Like what we have discussed. And list, we represent the list of vertices of the graph G here. And here we have a procedure that is going to update the matrix M here. Now what is M? It is adjacency matrix here. So you don't need to draw a graph here, sorry, a matrix here. But adjacency matrix will be what? It's a square matrix of how many nodes we have? 6, right? So it's a 6 by 6 matrix. And whenever there is age from one node to another, we'll say it is equals to 1 here. And first, we need to consider the adjacency matrix, and that will be taken as input to this particular procedure here. Okay. So we don't need to draw the graph. We just need to understand what the pseudocode is doing here. So let's discuss the procedure first here. So here we have temporary matrix equals to M. So we are creating a copy of this matrix, right? M is basically adjacency matrix for this particular graph here. Okay. Okay. Let me draw adjacency matrix, but you don't need to draw in exam. We'll discuss that. But for explanation purpose, we can draw it here. Okay. So here we have
Sir, this
0, 1,
question was also, sir, this question was taken by ma'am yesterday. The same
same
question.
code.
Same
Yes,
code,
sir.
yeah, same.
Yes, sir. Sir, please
Sir,
explain, but
please, yes, sir. Sir, I didn't.
Okay.
Actually.
Okay. We'll see.
So please explain this question.
Yeah. So we'll first try to draw adjacency matrix for this one. Okay, so 0, 1, 2, 3, 4, 5. So here 0, 1, 2, 3, 4, 5. Here also 0, 1, 2, 3, 4, 5. Yeah, please mute. Okay. So, so is there age from 0 to 0? Can we go 0 to 0? No. So where we can go from 0? By looking at this graph,
0
only
to
2,
2.
right? 0 to 2. So rest all will be 0. 0 to 2 only, that will be 1. Rest all will be 0. What about from 1? Where we can go from 1?
4.
Only 4. And rest it will be a 0. So 0, 0, 0, 0, 1, 0. What about 2? From node to where we can go?
1.
1 and 3.
2, 1, 3.
1 and 3, you can see outgoing edges here. So this will be what? 0, 1, 0, 1, 0, 0. What about a node 3 here where we can go?
0.
0.
Yeah, 3 here. So 0, right? 3 to 0. Okay, so this will be 1, rest it will all be 0. Okay. Now from node 4 where we can go to only 5 here, right? So rest all will be 0.
And from 5 we can go on 2.
And from 5 we can only go to 2 like that. So 0 1, sorry, 0 1 0 0 0. So this is basically adjacency matrix for given a graph here. Okay, so now this matrix is taken as the input for to this particular procedure here. Okay, now how it's going to get updated, that is what we have to discuss. Anyone, any doubt in adjacency matrix? I hope this is clear now, right?
Yes, sir.
Yes, sir.
Okay. Now this matrix taken as input here. Now temporary matrix equals to m. So we are creating one a variable which is basically a copy of this matrix. Now for each I in list of V. Now what is list of V here? It's a list of vertices of graph G. That is basically 0, 1, 2, 3, 4, 5. So here we have list of vertices of graph G. All list V you can see like that. It's a list of all the vertices. Now here we have nested a for loop here. Okay, you can see this indentation where it is closing like that. Now if you look at the outer for loop for I in J, so we are representing I for outer for loop for I in J. For the first iteration I will be 0. Then we'll go to a next line for J in list of V. J will be a 0 for the first iteration. Then for each K in list of V, again for the first iteration K will be a 0 here. Now what we are checking here, if mij equals to 1 and jk equals to 1, so here it is 0 0 0 0 here. Okay, so m 0 0 equals to 1. Look at this particular graph
Sir, what
matrix.
is K in
No,
this?
sir.
Sorry, what is
What is K in this?
k? Here you can see for each k in list of vertices. Similarly ij, here we have a k, we have a third for loop here. Okay, for the first iteration we are going so we'll go with start with the node 0 here, right? So here we have 0 0 0 0. So from m00 equals to 1, right? So do we have m00 means what? M, we have this row, we have this a column here, right? So zeroth row, zeroth column, that is basically this one. It is not equals to 1, right? So this condition is not true. So we are not going to do anything here, right? So here you can say if, then we have to go to a inner for loop, then k will be equals to 1, I and j will be equals to a 0 only. So like that we have to go, okay? Here you can see. Now you don't need to go through entire for loop, nested for loop here. Now what we are saying here, M is basically adjacency matrix, we already know. And in the adjacency matrix, whenever there is a age, that is basically represented as 1 here, okay? Now mij equals to 1. It means what? I have a node I have a node j, and there is age between I to j. Can we say like this?
Yes,
Yes.
Yes, right. And we have an em j and k equals to 1. So again, I have a node k. There is age from j to k like this, right?
Yes.
Now, if both conditions are satisfied, then only we are going for this one. If this condition is not satisfied, then we will not go to this one for loop here. Now, what we are doing here? Again, we have a for each L in list of V. Again, we are checking if KL equals to 1. I have a node L. So K to L equals to 1, right? If KL equals to 1, then what we are doing? Yes, anyone, what we are doing here? What is I,
We
L?
are creating an edge. We are creating an edge from I to L.
Yeah. So we are creating an edge from I to L. So we are going to update the matrix. It's temporary matrix here. It is basically a copy of the original adjacency matrix here. So I to L. Here you can see that is basically equals to 1. So if I say this is basically a temporary matrix here, so that will be referred to as 1. Okay. Now this will be a required case when all the conditions are true here. Okay. So I to J, J to K, and K to L. So then we are going to update the matrix to I to L equals to 1 here. That is what we are going to consider here. Simple, right? So if you go for entire for loop, we are going to update the value of this a temporary matrix for this scenario. Whenever we have this a 4 node I to J, J to K, K to L, in that case only we are going to update this particular matrix here. And then we are going to return this particular temporary matrix here. Okay. So that is what we are doing here. Anyone, any doubt?
No, sir.
So here we don't need to go through all the iterations here. Just try to understand what we are doing here. Okay. Simply check, we have ij equals to 1. So it means there is h from I to j, then j to k. Okay. If both the conditions are true, then we are checking for this one, k to l. And if all these three are satisfied, then we are saying temporary matrix equals to il equals to 1 here. So we are updating the matrix m and we are going to return that particular matrix here. Okay. Now, if I say what will the values of p and q at the end of execution of pseudo code given below. So basically new matrix is what? We are calling the procedure here with using this matrix M. That's it. Now P is basically new matrix 2, 5. So here we have new matrix 2, 5. So I, J, that is basically a new matrix I, J. So I is basically 2 and J is basically 5 here. So we want to find out 2 to 5 here, right? Like that. Now, what we can say about this one? So do we have age from 2 to 5 here in the original
No.
matrix?
Yes, sir.
No.
No, sir.
Now 2 to 5 we don't have, right? But here we are interested in updated matrix one. Updated one, new matrix here.
Sir, it is there, sir.
Yeah. So if you look at the scenario, so we have to check whether we can go from this 2 to 5 like this via J or K. So what is the value of J or K? We don't care. But if we can go like this, then it will be equals to 1. If we cannot go via like this, then the value of P will be 0 here. Now can we go 2 to 5 like this? So
Yes.
from 2, we can go to what? 1. From 1, we can go to 4. And 4, we can go to 5 here. So this is my I, this is my J, this is my K, this is my L here. So our condition is getting satisfied here in the pseudo code, what is mentioned here, right? It means what? It means what? We can go from 2 to 5 like this. So that is basically represented by 1 here. So we can see that is equals to 1 here like that. Okay. Anyone, any doubt here what we have done?
No,
So,
sir.
but there's no edge from 2 to 5.
Yeah, so we are not considering this graph now. Now this is basically new matrix after calling the procedure. So yum is basically this one. This is basically yum. Here we don't have the age, but we are taking this matrix yum as an input to this function and we are updating that matrix. So once we complete entire procedure, so here 2, 5 will be 1 here like that. Okay. And now if you look at a 2, 5, that will be a 1 here. Okay.
Sir, in the same way, if we are going from 0 to 2, 2 to 3, and we check, but no, this condition fails here. We cannot create an age from 3 to O because it is not L.
So 0 to
there will
2,
be just,
yeah, 3 to 0.
no, yes. So this condition will fail here, right?
Yeah, so this will be I, this will be J, this will be K. So we cannot go anywhere after that, right? So here, we
And
cannot say
similarly,
2, 0 will be equals to 1. No.
here 0 to 2 and 2 to 1 and 1 to 4. So we'll create an age from 0 to 4.
0 to 4, yes. So in the matrix, 0 to 4 will be a 1 here, like this. Okay.
Sir, in the new matrix, 2
Huh?
comma 5 becomes 1 and 5
Yes.
comma 2 was already 1. So this will become a like what should I say, undirected edge
No, we are not
between 2 and
updating the
5.
graph here. We are updating the matrix here. Okay,
Yeah, so
like that.
that particular edge can now go both ways from 2 to 5 also and
Yeah,
5 to 2 also.
yeah. We can say like that. We can go in both the directions, 2 to 5 and 5 to 7. This new matrix. Okay, in the case of new matrix.
Okay.
Now, what about this one? If you understand about the P, tell me the value of Q. Can we go to 0 to 5 via J and K?
No, sir.
So 0 to 5 we can go.
We
So we
0
can go,
cannot go
sir.
0 to 5.
So
to
we can go, but not
0 to
not in two hours.
No,
Sir,
no, we
this
No, no, we
cannot.
addition
We
can't
is
go
not
cannot
that.
go
fulfilling, sir.
directly.
Here
1
J is
to
2
4.
and K is 1 and L is 4.
Yes. So here
And they
the
transfer 5.
yeah. So here intermediate node will should be 2 here, right? I to J, J to K, K to L. But if you look at here 0 to 2, we can go 2 to 1 and 1 to 4 here. I can say 0 to 4 there is H here based on this particular pseudocode, right? But 0 to 5 I cannot say because here we have this I, J, K, L here. That's it. So if you execute this one, so I, J that is 0, 4 will be equals to 1. But 0, 5 we cannot reach here, right? So it will be equals to what? 0. Okay. So 0 to 5 we cannot go. 2 to 5 we can say. 0 to 4 we can say like that. Okay. So first just look at the pseudocode, what the pseudocode is doing. Okay. You can see the changes in this particular thing. Okay. Now just look at the code and just try to draw this type of graph. So we have I to J, then J to K. Just draw just 2, 3 nodes, connect them. And if this is true, then we have to connect K and L also. If this is true, then we are going to update I and L equals to 1 here like that. Okay, that's it. And here for loop is for just iterating through all the vertices here. We are satisfying this thing. So if you look at a 0 and 5 here, so let's say is I equals to 0, here K is 0, J also 0 initially. So anyway, 0, 0 is not the, here we don't have any age 0 to 0. So anyway, any condition will not get satisfied unless we update the value of J to 1 here. Okay. So J1, M0, I0. So 0 to 1 also we don't have any age. So anyway, this will not get updated because here and condition is there. Now here we
Sir,
have,
in matrix from K to L, if it is not equal to 1, then we will say for both these conditions we get 0.
sorry, can you repeat?
If K and L, that
Uh,
is given in the matrix, if it is not equal to 1,
hmm,
then we can say that answer will be 0 for both, right?
yeah, then I to L we cannot say equals to 1.
Okay.
Okay. So if you look at this one only, 3 to 0, do we have any matrix? Yeah, so here 2 to 3, here we have H, 3 to 0 also we have H, and 0 to again we have a 2 here. Okay, so that is basically the same thing. Yeah, for this graph it will be a cycle. Okay. So when j is equals to 2, after going to all the iteration for j equals to 0 and going to all the values of k, then j equals to 1 going to all the values of k. Now here 0 2, now this condition will get satisfied because we can go from 0 to 2. Also, if you look at the this matrix M here, 0th row, second column is basically equals to 1. Now our condition is getting satisfied here. Now we'll check for this one here. Okay. So 0, 2. So j is basically a 2 here. Now for which value of k this will get satisfied? We have to find out. For 1 only, right?
Sir, what we are doing here, actually, we have found the values of P and Q. After that,
No. So we are trying to understand how these for loops are working here. Okay. Nested for loop.
so can,
So
can you
first,
can you please repeat, sir? Bit.
yeah, so we are trying to understand how these for loops are working. Nested for loop here. Okay. So
Okay,
list
sir.
is basically list of all vertices 0, 1, 2 till 5 here. Right. All these things are basically same thing here. So first iteration will be what? Outer iteration I0, J0, K0. But for which condition of ij this will get satisfied. For any value of, let's say for example, I is 0. So we'll keep I equals to 0, we'll keep j equals to 0, we'll iterate for all the values of k. This is how for loop works, like this. But for
Yeah.
any value of k, for I and j, this is not true. So this will never become true, right?
Doubt?
Because we have AND condition
Yes,
for
sir.
j0
Yes.
and I0. Then we'll exit the inner for loop. We'll go for this for loop, update the value of j to 1. Now, in that case, I is 0, j is 1. So, I is 0, j is 1. Do we have a age? No.
Hmm.
So, doesn't matter how many times we go through the k for loop, this condition will never become satisfied. Now, we go for again next middle for loop, that is j equals to 2 here. Now, when j is equals to 2, I is still basically 0 because we need to go through all the values of j first, then only we can go for an outer for loop. Now, if you look at here, j equals to 2, I is equals to 0. So 0 and 2. So we can now see 0, 2 is basically equals to 1. Now this is our condition getting satisfied. Now check for this one. And so it should be satisfied for both the conditions here. Now we need to find out which value of k will satisfy this one, because I know I to j equals to 1 and the value of j should be 2. Now for which value of k this will be satisfied?
Sir,
From I
one and three.
1 and 3 here, right?
One and
So when, yeah, 1 and 3, no, not 5. 5 is incoming edges. We want outgoing edges from 2 to that particular node. Row is basically 2, right? You can see here.
one or two.
Yeah, 1 and 3 only, right? So now we'll iterate to the for loop k equals to 0, 2, 0. No, then not true. Go for next one. K equals to 1. Yes, 2, 1 is basically equals to 1. Now here we got to satisfy our condition. Value of I is 0, j is 2, and k is 2. Now we'll go for this for loop. For each L in list of this one. Again, we'll try to compare. So our k is fixed now because we have checked for this condition. Then only we have entered the for loop. The value of k is 2. Now, for which value of k this will be true?
5.
No, for which value of L? So 2 is already there here, right?
3 or 5, 3 or 1.
Yeah. So from 2, we can go to either 3 or 1. So again, we can go to 1 here.
Sir, if it was like from 0 to 0, will it be possible?
No, 0 to
And
0 is not possible here.
sir, for which
Sorry.
value of the first if statement is true?
Yeah, k is 1 here. Can you repeat for which value of?
Sir, for which statement the first if statement is true?
So both the condition must be true here. And if you look at in the outer for loop, we have I and j. So when I is equals to 0 and j is equals to 2, then only we can say we have 0 to 2 here. We have a h. So this will get satisfied. Okay.
Sir, and means both should get satisfied, right?
Yes.
And IJ
So
and
when 0
IJ.
and 2, we are checking for first condition. Then we have to check for this condition. Now we have fixed because we know that 0 to 2 will be equals to 1. Now the value of j is basically 2 here. Now we have to check for which value of k this will get satisfied. Because if you look at the k here, k will keep going to iterate. K equals to 0, not satisfying. K equals to 1, yes, it will get satisfied like that.
Okay, sir, understood.
Okay. So you don't have to do all those things. Simply try to draw this particular graph from the code. That's it. Okay.
And sir, for each L then the next statement, next
Yeah.
line 7, 8, 9.
So
7, 8.
this is 1. So here we have k equals to 1. Okay. Now once we got this condition satisfied, we fix the value of k here, that is basically equals to 1. Now if k is equals to 1, for which value of L we can say it is true, because L will keep iterate. L equals to 0, not true. L equals to 1, not true. L equals to
4, sir.
2, not true. L equals to 3, not true. Again, next iteration, L equals to 4, yeah. Now, when the value of L is basically equals to 4, now this is getting satisfied. Now, the value of I is 0 and the value of L is 4. So, 0, 4 will be 1. So, we are going to update the matrix 0 and 4 to 1 here like that. Okay. So, this is how this all for loop will works.
Sir,
Okay.
but 0 to 4, there is no edge, right?
Yeah, in this graph, it is no, there is no edge, but we are updating that particular graph here.
Okay, that's a procedure. Okay.
Yeah. So we are calling a function, we are taking this graph as the input, we are updating the graph here. So updating the matrix here. So in that
Okay,
case, you can find out the value of this one. Okay, great. Anyone, any doubt now in
Sir,
this
there's a
question?
question in the chat. Can you solve that?
Based on same concept or what? If you have any
Yeah,
other
same
question,
concept.
we'll discuss that later. But if which question I'm not able to see.
Sir, I tagged you. Like, see at the
It's
end of the
from the
chat.
graded assignment, right? The question is from
Yeah,
the graded assignment,
yeah.
11.
Okay. Okay. So we'll discuss that. Okay. Let me discuss this one. Then if you have any doubt, you can share the screenshot. We'll discuss those questions. Okay.
Okay, sir.
So those based on the dictionaries, I guess you have shared, right?
Yes,
Submissions.
sir.
Okay. Okay. We'll
Yes.
discuss. Okay. Great. So whenever you come across this type of thing, right? So always check the best way, instead of drawing the adjacency matrix and check all those things, just check for this if conditions, how it is going. So I to j we have one, j to k we have one, so we should go like this. And again here we can see k to l. So we have one more node, k to l will be again there is h. Now if this thing is satisfied, then only we are going to update the matrix to I to l like that. Okay. So if you look at the previous year question, you can see the graph will get changed and few changes will be there in the code like that. Rest pattern will be like that. Okay. So again, we have a same graph, but here we have changes in the code. What we are doing here. So same thing. Every for loop is going through all the vertices and trying to satisfy this particular condition here. What we can see here, if you understand the previous question, tell me.
So
is
we are
this
increasing the count here if there is an age from I to J, J to K, and K
K
to
to I?
I.
Yeah.
They,
So I to
they
j.
form a click,
Yeah.
and J to
Correct.
K, and then K to I.
So here,
There
if
is a
I to j equals
third,
to 1. Yes.
yes.
Is 3 is the answer here.
And then the
Okay.
count is increasing.
So we want to find out the value of count here, right?
Yes.
It's finding for how many clicks are there.
Okay, we'll see. So if you look at the condition here, anyway, we are iterating all the vertices here. But the thing is here, if ij equals to 1, it means what? We have h from I to j and j to k is equals to 1. Here we have j to k equals to 1. Then we are checking for k to I equals to 1. Do we have h from k to I like this equals to 1? Then only we are going to increment the value of count here. Right? Count starting with a 0. So what we can say
Yes,
about
sir.
this I,
Yes, sir,
j
we have.
and k here. I to j, j to k to I here. So we can
0
see
to
there is a cycle from I to like this I, j, k.
0 to 2, 2 to
yes,
3,
sir.
3 to
0 to 2, 2 to 3, 3 to
Yeah.
0.
So any node satisfying this one, you can see 0 to 2 to 3, 3 to 0, right? Do we have any other that thing which will satisfy this particular cycle here, having 3 nodes?
No, sir. No, sir.
No,
No,
sir.
sir.
No. So what is
No.
the answer here?
1.
Sir,
1 or 3?
So it will be
Sir,
3 because we
there are three
updated the
nodes.
graph in the previous
One
question,
five
right?
0, then 2, then 3.
No. Don't consider this previous
Yeah, it will
question.
be
Okay.
1.
1, 1, sir.
This is a separate
Sir,
question
it's
here.
1, sir.
1.
Okay. Then
So
it will be
answer
1.
is basically a 3 here. Okay. So we are finding out how many times this count is getting incremented, right? So first we start with 0, 2,
Oh, okay,
3.
okay.
So value of I will
0
be
to
0, j will be 2, k will be a 3. So
3.
count will be 1.
Yes, sir.
Then 2,
Then
3,
2,
0
3, and
also.
0. Yes, sir.
Again
Again,
2, 3, 0. Then
Yeah,
3,
we are
0, 2
And
correct.
also.
yes, sir. 3 times.
We're
The
iterating.
value of
Oh,
I,
yeah,
j, k
yeah.
we are going to get because we are iterating all the vertices here, right? For loop. The value of
Yes.
count will be a 3 here. Okay.
Yes.
Yeah. So here we need to check for every condition, okay, because we are iterating for all the values of vertices here, like that. So here answer will be 3. Anyone, any doubt here in this question?
No, sir. No,
So if we give any graph here, if we simply change any condition, you should be able to answer the question here. That's it. Again, similar type of a question. Tell me what is the question here? Okay. So here we have the graph. Here we have adjacency matrix. We have the procedure like this. And tell me what we are doing here. So we are taking M, that is basically adjacency matrix, as an input, and one Q, that is a vertices here as the input, and then we are going to return the value of count here. Okay. So what we are doing here?
They are
Is this question discussed in previous session?
We are checking, sir.
But in this we
Huh?
are checking if there is a outgoing edge
If there is
from
outgoing and incoming edges.
from I to Q there is an edge, and then Q to K there is an edge simply, and then we are
I
increasing
to
the
Q is an
count.
incoming edge and Q to K is an outgoing.
Okay. So here, can we say I to Q and then Q to K
Q to
here,
K.
Yeah.
like that, right? Then we are increasing the value of count here. Okay. Now, what about this one? We are taking M as an input. The value of Q is basically 1 here.
It will be 1. Count equal to 1.
It will be 1, sir. 1 to 2 and 2 to 5.
So value
No,
of
0 to
Q,
1 and 1 to 2.
yeah. So here the middle Q is basically what? A 2 here. We need to check for this one. Sorry, not 2, 1 here. Q is basically 1, right? It means what? What we are checking here? So do we have a edge which is incoming arrow to this
Yes,
Yeah,
sir.
0 to
node,
1.
and
Zero
then
to
one
Yes, sir.
edge from outgoing here, like that. So here the value of Q is basically 1. So we are checking for the 1 here. So from here, can we say like this? Yes. Here we have the value is basically count equals
Sir,
to 1
but the
only.
node given here in the question, it is asking M is 1. So it means that it is a starting point, or
No,
it is
M is
taking
Midpoint
the
not
point.
middle
1
value.
here.
That's the midpoint, I think.
So here M comma 1, right? So the value of Q is basically a 1 here, right? M is basically this adjacency matrix of this particular graph. Now we have to consider Q equals to 1. So we have to check for which node we are getting incoming and then outgoing edges, like that. Okay, so, and we are counting that. For 2, can we say, sorry, here we just have dealing with Q equals to 1 only. So we are checking for node 1 only here. Okay. What about a second one? If Q equals to 5, what's the
0.
answer here?
0.
0.
Q equals to
There
5,
is
we have
only
I to 5
incoming,
equals to
no
1. For
outgoing.
value of I and
there is no outgoing
yes,
edge.
The
but there
zero,
is no
sir.
outgoing edge here. 5 to K, we don't have any K here, right? To
Yeah.
go. So here answer will be a 0, like that. Okay. So just look at the pseudocode and try to understand what that pseudocode is doing. And simply you can consider this particular case here. Whenever you can see the condition like that, simply try to draw the graph like this and see which answer you are.
Incoming edges are two.
Sorry.
Here incoming edges are two, so don't we have to count it?
No, we are only checking for the node 1 here, for node 1. Okay. So we are checking this one. Okay. How many incoming edges we have here, like that. So let's say, for example,
So for 3, it will be 2. B will be 2 for edge number 3.
okay, yeah, we'll discussing that only. Let's say, for example, Q equals to 3 for given graph. Tell me the answer now.
Q is equals to 3.
2. 2 is an.
Two, sir.
4,
2?
3, 5 or 0, 3, 2.
2,
Yeah.
sir.
So here the value of Q we have fixed, that is basically a 3 here. Now, for which value of I this will get satisfied? You know, we have two options here, either 0 or 4, but first we'll go with the 0. So 0 to 3, we have a H, but 3 to 5 also we can go for value of K, right? So
Yeah.
this will increment by 1. Then again we go for each value of K, but there is no other value here of K which satisfy this one except 5. So we'll go for outer for loop. Now again we change the value of I. Why I equals to 0 satisfied, I equals to 1, 2 will not satisfy, 3 anyway not satisfy. When I equals to 4, what will happen? I equals to 4.
If I is equals to 4, then there is
Again,
no
4
4,
to 3
3,
we
3,
have
5.
3 to 5 anyways.
0
The
to
value of
4.
count will be 2 here. Okay.
Yes, sir.
Okay. So what will be happen in this scenario? Now we have one more H 3 to 2. Now tell me answer.
Four.
Yes. 4 here, right? So we'll get 4 combinations here. 0, 3, 2, 0, 3, 5, 4, 3, 2, 4, 3, 5, right?
Yes.
Answer will be 4 here.
Can you explain again this part, sir?
Yeah. So what we are saying, we have one more H 3, 2, or 2 like that. Now we want to find out the value of count here, and the input is basically Q equals to 3 here,
2, 3.
right?
Okay.
Now if you
And
look at, yeah,
Count equal to 4.
yeah. So 0 to 3, but 3 to 2 we can go, that is count 1. 0 to 3, but the value of K will be 5, then in that case we can go here, count will be 2.
Okay.
Then in
2.
the outer for loop, I will be 4. In that case, we'll go for a 4 index, vertices. Then we'll 4 to 3, 1, 3 to 2, again 1, then 4 to 3, and
count
3 to
4.
5, again 1. That will be a 4 here.
Yes, sir.
Okay, great. So this is basically based on the graphs here. So this is basically week 9 and 10. So you can expect this type of a question in the end term. The graph will be given, the code will be given, and you need to find out the answer for the given scenario here. Okay. Okay, so this is
0 to 3, 3 to 2, how, sir?
0 to 3, 3 to 2. Yeah, so we are saying that we have one more H. In that case, answer will be 4 here. Okay. Like
Okay,
that.
sir.
Okay. Okay, so this is basically based on the graphs. In week 11, we have important concept recursion. You can expect 2 questions based on the recursion here. So recursion means what? We are calling the function inside the function here. You can see do something. Again, we are calling the same function inside the same function here. So here we have 3, here we have 2. Tell me the answer here, what we are doing.
We are subtracting the second
Sir,
value
1, sir. 3 and 1.
from the first.
Okay,
2,
what is the
3
output
minus
then?
2. It will be
9.
it will return X value.
Miss 3.
3 is correct?
Sir,
Or
3,
what?
sir.
9?
Yes.
Okay, we'll see.
9, sir.
Okay, we'll see. Here we have 3,
So it's
here we have
multiplying,
2.
then it will be 9. There is a multiplication sign, right? So it will multiply and then it will be 9.
Okay, we'll see. So x3 and 2, this is the input you have taken, and equals to 0. No, go to else block. What is written here? X into do something. What is x3 multiplied by do something x comma n minus 1? Now the input is what here? X
It will,
is basically 3,
3, 1.
3
3,
comma
1.
1 here.
will it print 3 times?
No, we'll see. Now again we are calling the same function here. For the input x equals to 3 and equals to 1. What will happen? Anyway, n is not equals to 0. So we'll again execute the else
Multiply
block
by
here.
3.
Again going to multiply by 3 into again do something. X is basically 3 and
0.
n is basically what? 0
0.
here.
Yeah.
Now what's the value when we take do something 3 comma 0? N equals to
1.
0 here.
1.
That is basically a
It will be
1.
0, then it will.
Yeah, n is 0, right? So that is basically a 1. Now the output of this thing is basically 1. So 3 into 1, 3. Now output of this is basically 3 into 1, that is 3. So 3 into 3 will be the 9 as the answer here. Okay, like that. So here we are doing, here it is working in that particular manner. Okay. So whenever you come across this recursion, now always follow this tree type of structure here. Okay. So that you can go backtrack and you can do the calculation here like that. Anyone, any doubt in this question?
So, can you summarize this again?
Explain again.
Yes, sir. Please summarize
Yes.
it.
Okay. So here we have 3, here we have 2. We are calling the functions here for this input. So the value of n is not equals to 0. So we go to else block here, return. Now here we have x into do something. But the value of x is what? 3 into do something x in comma n minus 1. So here we have to take the input x is basically 3 only and n minus 1 is basically 1. Now again we are calling the function do something for input 3 comma 1. So how it works, again we are going to call this procedure. Again check all the lines here, n equals to 0, no, go for else block. Then we are going to return x into do something, but what's the value of x for this input? Again 3 into, again we have to take do something here, but in this case x will be 3. Now what's the value of n minus 1? Because n is basically 1 now, that will be
0.
0. Again we are calling the same function here. Again we go for a, here inside the function we'll check n equals to 0. Yes, now it is going to satisfy n equals to 0. We are going to return 1. So we have written a 1 here. Now we have to do the calculation. We have to back fraction here. Now the output of this is basically 1. So 3 into 1, 3. Now output of this is basically what? 3 here. And 3 into 3 is basically a 9. So 9 will be the answer here. Okay. Like that.
Okay, sir. Thank you, sir.
So if you understand this, try to solve this question. Tell me the answer here.
Sir,
We
in the
have a
previous question, as you in the
yes.
previous screen, you were saying like return 1 when it is equal to 0. Then
Yes.
how it is going to go back to this return value of the previous step? 3 multiply 3.
Yeah.
Because
So here,
if the condition becomes 0, then it will be returning 1, right?
yes, that is the value of this function here. Okay, whatever we have got inside this one. So output of this is basically 1 here. The output of this function multiply by 3 we have to do. So 1 into 3, that is basically 3. But this is the output of this particular function here we have called, right?
Oh, okay, okay. Get it.
So in that way we are going, we are taking the output of every functions here. So this
Okay.
will be much clear to you. This is, now tell me how we are going through this. We have a list, we have a yes. So this posture is given to us. List is taken as the input. X is basically 4 minus 2, 3, 1 here. So length of ex and x is basically this one. So not equals to 0. We go for this if statement. It is equals to 1. No, because length of n is basically what? Number of elements. Here we have 4. So we'll go to a return statement here. What we are doing here? First of x. What is first of x?
Uh,
4.
remaining except the first. Minus 2, 3, 1.
No. First and last will give the
4.
element. First and last element. Okay. That is init and rest
4 and 1.
you are talking about. Yeah. So here we have first, that is the first element. Last is basically last element here. So here we got 4 minus 1 plus the output of this function. But what is this? We need to calculate. Again, what is rest of init of x here?
Minus 2,
Minus 2
Minus
and
2
3.
and 3.
Comma 3, comma
Yeah.
1 is the rest value.
Yeah. So
Init,
init function will remove the last element and rest
minus 2.
function will remove the first element. So minus 2 and 3. Now the output of this will be minus 2 comma 3. And again we are calling the function here like that. Okay. Now tell me, again we are calling this particular procedure. Length x equals to 0. No, we have 2 element. Length will be 2. Length x equals to 1. No, we have 2 element. Go for return. Now what is going to return here? Again same thing. What is first of x? Now x is basically this one now.
Minus
Yes,
5.
minus 2 minus last element of x minus 3 plus compute value. Again rest and init of x. What is the value of rest and init of x then? Tell me here. X is minus 2 and 3 now.
Sir, empty list.
That is
Minus 2.
basically an empty list here. Okay.
Empty list.
Init of x will remove the last element. 3 is removed. Rest will remove the first element. So anyway, we have just one element. So minus 2 will get removed. So here we have empty list. But again, we are calling the procedure here. Again, we are checking. Now tell me what will happen. What is the length of x now?
0.
0.
0. So it is going to return what? 1
1.
here. But 1 is the output of this function here. Okay, so output of this function is 1. So this is 1. So minus 2 minus 3 plus 1, the value is what? Minus 4, right? Minus 4 is basically value of this function. So 4 minus 1 plus minus 4.
-1.
Answer will be a -1 here.
Sir, how it became -3?
Where -3?
-2, -3, you said no.
Okay. Yeah.
Yeah.
So here we are taking -2 and 3 as the input. Now length is not 0, not 1. We go to return statement. So first element of x, that is basically -2. So first element of x minus here we have. So minus will come. Last
Okay.
element of x is basically 3. Okay.
We called the
Yeah.
procedures.
Plus, then again we are calling the procedure again here. That is what recursion is. Calling the function inside the function here. That is what recursion is. Okay, so answer will be a -1 here. So you can go in this particular manner like that. Three-type structure. So it is better to do a calculation.
Sir, can you repeat the third step, sir, again?
Huh? Yes.
The third step, sir. After empty list, sir.
Yeah, after empty list, right? So we are again calling the function here, but the input is now we have removed the both the element, that is empty list here. Now if I call this procedure, again we have to check length of x, but x is empty, so length, there is no element, so it will satisfy this condition. Length of x is 0, yes, it is going to return 1. The output of this entire function is basically a 1 here. Now we have to take here, so -2 -3 plus output of this function is basically 1, so that will be a -4. That is the output of this function here. Okay. So be careful while doing the calculation in this particular case. Okay.
This init and rest functions, we can apply only on the list, no? Not
Yes,
on
only list.
not on dictionary, no?
No, only list.
Okay.
Okay.
Thank you.
So in the Saturday session, I think I have discussed entire week 5 to 8 content. In that we have discussed about list and dictionary. Okay. Okay.
Sir,
So
could you explain about after -4 how -1 came?
4 -1 here.
Yes, sir.
Okay. So for the first thing, right? So when we are calling the function for the first time here, input was this one, right? So we are taking this as the input. Length anyway will not satisfy because number of elements is not 0 or 1. We are going to return this one. Now, based
No,
on
sir,
this,
sir, I'm asking that you have written in green color. 4 -1 plus -4, that way.
okay, this one. This is basically here the calculation. 4 -1 plus the output of this particular thing. That is basically -2 -3 plus 1. That is -4 here. Okay. This is the calculation we are doing here. 4 -1
Okay.
plus -4.
Okay.
That is output will be minus. Okay. Great. So that's it from my side. If you have any question, you can share your question. We can discuss those questions now.
Sir,
Last step, sir,
I have
again, sir.
doubt from the April 2025 CT paper, sir, and term paper.
Sir, sent in the chat.
Okay. So please share your question in the chat. We'll go one by one.
Okay,
So
sir.
first, Saikat has shared. Let me take that one. Saikat, this is the end of full question, right?
I have tagged you in one. The rest of the question is above. I'm tagging you there also.
Okay, the question is this one only. We have a procedure, then we have the submissions, and then we need to find out what's the value of submissions only, right?
No,
Okay.
there is like something else also.
Okay. So
Just
which exercise
I'm
can you tell
resharing
me?
it
We'll
again.
take that.
Sir, can you repeat the last step, sir?
It's a graded assignment 11.
Week 11, which question?
Week 11.
It is on the
Just a
top,
second.
first or second.
It's question 2 and 4. 2 to 4, I mean.
Okay.
Sir, can
Okay,
you
question.
repeat once, sir, again, sir? This last step I didn't understand, sir. How -1 came, sir?
Okay, calculation bad. Okay.
Yes, sir.
So you understand this, how we are calling the function again and again, right? So
Yes, sir.
minus 2, minus 3, plus again we are calling this function because we need to execute this one. But here input was x, that is basically minus 2 and 3. So init will remove the first last element, rest will remove the first element. Now this will become empty. Now empty list is taken as an input to this particular function, compute value, right? Now length of x, that is this number of element in the list, is what? 0 here, because the list is empty. Now our condition is getting satisfied here. So we have to return 1. But this is the output of this function, not the entire function here. So this will return 1. Okay. But here we have to do calculation minus 2, minus 3, plus the output of this one, that is 1. So that is basically minus 2, minus 3 plus 1 will be a minus 4 here. So minus 4 is the output of this particular function here, right? So we are backtracking to the previous this call here, like that. Okay. And here you can see we have 4, then we have minus 1, plus the output of this function is basically minus 4 again. Okay. So if you do calculation, we'll get minus 1 as the answer.
Okay, so got it.
Okay. Yeah. So week 11, graded assignment question 2 to 4. Let me check that. Week 11. Okay. Is this visible?
Yes, sir.
Yes, sir.
This is the question, right? So here we have auto grading system for online course in the following way. Students have been recorded dictionary. So dictionary role is key mapped to a student roll number. So you can see roll number will student roll number. Time of submission, score is basically student score for that submission. So each student can take multiple submission before the deadline. Here you can see. And every time student take multiple submission, the dictionary is corresponding to it appended to the end of the list. So you can see this is scores dictionary we are going to get. Okay. So what is this course? Yes, anyone? What is this?
It is a
Course
list.
is a list.
List of dictionary.
Yes, sir.
Yes.
Every element is dictionary here, right?
Yes.
Okay.
Yes, sir.
Now consider the pseudo code. We have a procedure is present. Okay. So L will be what? I guess it is used here.
Sir, how you will understand that this is a this or something? I am not able to understand it.
No, see, list is basically start. Yeah, list is indicated by the square bracket here. So you can see the square bracket, right? So that means it is basically a list. Dictionary is represented by this curly bracket here. Okay. So you can see this curly bracket here, right? So outer you can see here, it is a list, but every element before comma, you can see every element is basically a dictionary. It's a list of dictionary here. Okay. So
But
you
sir,
can see.
when I'm doing the when I'm solving the question, then I'm testing so many types of like keys and values, something that I am not able to assuming like this is a city or there is a I will assume the city and I will there I will assume the entity or something. I'm not able like this. Sometimes written in the question in the how we will understand and how we will assume that is key and that is value.
Yeah, so you can see, okay, whatever is there. So if we have a dictionary, then the left side will be a key and colon after that it will be a value only. Okay, this is how key 1 value 1, then we have key 2 value 2, like that. Okay, this is what a dictionary is, key value pair.
Sir, theory I know.
Okay.
Left side like keys and right side like value and key is never value can change, but key is not change. This key is unstable. So that I am understanding this, but I am not understanding to assuming in the question. When I am saying the question, when I am opening the question, solving, then I am not assuming. Okay, here I will assume like assume city or the value and marks and total marks. Then I am not able to
Yeah.
assume the key value of marks and something.
Okay, okay. So first you should know about the various functions we use for dictionary. Okay, so is keys of that particular dictionary, like that. So we have discussed this all thing in detail. So both the topics I have discussed in detail in Saturday's session, the previous Saturday session. So please do watch that session. Okay. So I have discussed both the things in detail along with all the questions from quiz 2 previous term. Okay. Yes, Gautam. Okay. So here we have the scores, basically a list of a dictionary. Here we have a pseudocode. Okay, procedure is given to us. We'll see is present, is there. Yes.
Sir, I have a doubt. In the procedure, upper code, yeah, here. In the procedure code is present, the L represents the list and the role represents the key, no?
Yeah, so we have not discussed that. So you can see L and role, it can be anything. But if you go inside, you can see for each D in L. So L must be a list here. Okay, that's how we can iterate for a entire for loop here, like that. Okay, so we'll see L is basically a list and role is basically a one particular value, we can say. Okay, we'll see how this works because we are going to use this in this particular procedure here. Right, so here we have a procedure get subs L. So we are doing this one. Then based on this, we need to find out the value of a quotient 2 here. So scores is given below. Submission is what? So here we have an input scores. Then we have a submission get subs scores, right? So we are calling this particular procedure for this particular input here. Okay, this is what a given thing is, and we need to find out the submissions here, output of this particular thing. Let's try to solve this question. So we are taking this scores as the input. Okay, first sub, res sub. So first is basically fs is basically empty dictionary, and rs is basically a what? Empty list. Here we have, if length of L is less than equals to 1, is this correct? You can see here. So here we have 5 elements in the list. That is not correct. So
False,
we'll
sir.
go, yeah, we'll go for this line directly. What is first of sub? First element of the list. What is first element of the list here?
Rule 12.
Rule 12. Time
Not
10.
roll
No,
12.
first dictionary.
Entire dictionary
First
here.
entire
Yeah,
Yeah,
first.
the entire dictionary.
So this is basically my first element. What is rest of a sub here?
Rest of the dictionaries
So
for the four rules.
this one, right? So this is basically my RS. This is basically my first sub. Can we say like this?
Yes, sir.
Okay. Now we are calling if is present rest sub. So we are calling the function here, this one. Okay. We are taking the rest of the list as input and the first sub roll number. So here first sub is basically this one. What is the value of first sub roll number here? Yes, anyone?
12.
12.
12.
Sir, can you
Right?
explain this again, sir? This part.
Yeah. So here we have stored first sub equals to first element of the list. So that is what
Yes.
we got here. That is a dictionary here, right?
Yes.
Now we are calling first sub in bracket. We have a roll number. So if we have a dictionary and if we put a key here, we are going to get the corresponding value for this particular key here. If we look at roll number is basically a key. So for this roll number, what's the value here? We have 12, right? So here the output of first sub roll will be a 12. Rest sub will be the remaining list here. Now we are going to take this remaining.
Sir, 1 minute. Sir, how it is 12, sir? Because there are many roles.
No. We are just dealing with the
Okay.
first submission here.
Okay,
That
sir.
is basically a first element of the list. So first dictionary only, right?
Okay, fine, sir. Fine.
Yeah. So this is basically a first sub and remaining is basically my rest sub here. Now we are taking this list as an input and 12 as an input to this particular function here. Here we have 12, here we have that array sub. Now what we are trying to do for each t in L. So for every element in the remaining list here, okay. So what we are trying to do here? Yes, anyone? T of that roll number.
So, L is the original list or remaining?
No, we are calling this function for this input rs here. If you see rest of sub,
Okay,
right?
okay.
So it will be a remaining list, this one, this 4 1. Okay. Now for this one, we are calling one by one. For every t, means first we'll go for this list here. Now this basically element of rest of sub. Is this correct? That element, and in bracket we are putting roll number. It means what? We are taking the value of this roll number, that is 20 here, right? Is 20 equals to this roll number 12? Is this correct? No. So we are going for a next iteration. Next iteration is basically my this dictionary, this element. Again, we are taking roll number here. The value of roll number is basically a 12. So again, we are trying to match with the value here, dictionary roll number for that particular dictionary 12 here. Again, you can see here it is matching now. Now, in this case, it is matching. Then we are going to return true here. So in this case, we are going to return true here. So is present, entire thing is basically true. Okay. And then we have to return this one. So again, we are calling the same function for this dictionary, remaining one. Okay. Like that. So again, what will happen now? Tell me if I call this same function for the remaining dictionary.
At first it will return false, right?
Yes, sir, because its length
Sir,
is
can you explain what
So
happens?
the role is 20 in the procedure is present, the rest list is going, but the roll number is 20.
So what happens after the function returns true for 12 is equal to 12?
Sir, you're not.
Sir, you are not audible.
Hello, bro. Anyone can give me
Hello.
Telegram ID so that I will give you something.
Hello.
I'm
Am
not
I
able
audible
to.
now?
yes, you are audible now.
Bro, we don't speak Mandarin.
Okay. There's a power cut here. That's why. Okay. So yeah. Now what we are doing? We are taking the remaining.
Sir,
Yes.
so in the rest list, the roll number which you're checking, the T of roll, that key, that is 20, right? So you're checking 20 is double equal to 12. So it will return false.
No, for this case, you are talking about the first iteration, right? For the first list
Yeah.
here, you can, yeah. So here the value is 20. Now 20 is equals to 12. No, that is
No.
false, right?
So it will
So
return
we are not going to
false.
execute this one. No, we are not going to return false. It is inside the for loop here. We have to go for a next
Oh,
element, next iteration.
okay,
Okay.
yeah.
So what we are doing, we are simply checking whether this key is present in the subsequent dictionary or not, right? So here 12 is present. Yes, you can see. So that's why we have written a true here. Now again, we are taking the remaining sub list here. That is basically what
The 12, sir.
here, this one, right? Now again, we'll consider this as my first sub list, right? This is what
Yes,
we
sir.
have
Yes,
done
sir.
previously, right? Now here roll number is 20. Again, we'll
Yes, sir.
call this is present. Again, we'll check with the remaining one here. Is roll number 20 present in the remaining
Yes,
roll
Yes,
sir.
numbers? Yes. So again, that will return true. So again, we have to call the same function here for the rest sub here. Now the rest sub will be what? This one. We have removing one element here. Is 12 present?
Yes, sir.
So this will be my first sub, okay? In the third calling of that particular function, this will be my remaining sub. Now again 12 is present in the remaining sub. So we are going to this will be a true. Okay, so 12 of 12 will be equals to true. Again, we are this thing. Okay, so again we are calling this function, taking this as an input. Now tell me what will happen if I take this as an input here. Return get sub, and rest sub is
True.
basically this one.
Get
Now in
true,
this
sir.
case, first sub will be my first element here. That is basically roll number 12. You can see first sub is basically the first element of the list, and rest sub is remaining of the list. That is basically this one. Now, whether this will get satisfied, 12 and 20 we have. So whether this will get satisfied here is present. So we are checking for 12, but we just have one element in the dictionary, that is basically that entire dictionary last one, but that is equals to 20. Now
Yes,
here
it
20
will.
is not equals to 12. We go for next iteration, we don't have any other element. Then in that case, we are going to return what? False here. So here we are going to return false. Now remember, the output of this thing for the fourth calling of this function is basically false here. So in that case, we are going to go for else block here. And what we are doing?
We
We
are
are
returning the
returning the
First
first
sub.
plus the rest of
Yeah.
the like that.
Now what is first sub here? This one was the first sub, right?
Yeah, it will basically
What?
return them back to back, right?
so
Yeah. So this is first sub plus get sub rest of sub. Again, we are calling this particular function, but only one entry
Yeah.
is there. Now what will happen?
So the
Only
first
one
if else
element.
will get executed.
Yeah, this one, right?
Yeah.
Length is just one. That is true. We are going to return that DL, whatever we have in the output. So this will be get merged with this one. So output will be these two elements only, right? In the list. So I guess 1220 will be the answer. We'll see. 1220, we have two options, but 2350, 2353, right? So this will be the correct
the
one
C,
here.
sir.
sir, can you explain this,
So
sir?
it will just return the last two, right?
The last two only you can see here.
Okay.
Yeah.
Sir,
Because what we are doing every time, we are taking first element as a list and remaining will be a, sorry, first element as a dictionary, remaining will be a element. We are checking the key is present, whether we are checking the value is present in the remaining sublist or not. If it is present, then we are removing the first list again. Again, we are checking with the remaining sub here. This is what we are doing. So 12 is present. Yes, we have removed 20 is present. We have removed again 12 is present. We have removed. Now we left with this two only. But here we don't have any other thing. So at the last, return will get execute. Sorry, else will get execute, and this is going to get returned. First sub is basically my first list, and remaining will be my this one. Okay, output will be this two list.
sir, can you repeat this briefly because I have not got clarity on that. Like, actually.
Okay. Okay, so what we are doing here, we are taking the list as the input. We are taking the first element as my first sub. That's it. So every
Yes.
time what we are doing, we are taking first element here, and remaining will be my remaining list. Now we are trying to match whether the value of this roll number is present in this particular remaining list or not. If it is present, this is what we are checking, is present, right? So in that remaining list, we are present checking that whether roll number exists or not. But 12 is present, so we are going to remove this one. Now we'll consider this one as a input. Again,
Sir, why
in the
not we
next,
consider second one as the input, roll number 20? First sub will be the
yeah,
roll 20, na?
that is what we are saying. So after second call here, this will be taken as a input entire thing. Now in second call, this will be my first sub, and this
Yes,
will be
sir.
my remaining sub. Again, we are checking 20 is present. Yes, so that is true. So then remaining sub is taken as the input. Then again, we'll take this
Sir,
as my first sub and this as my remaining sub here like that. Okay.
sir,
Again,
So
12
in
is
the
present.
as
end, what happens, sir? After that,
Yeah,
we
in
take
the end,
last.
you can see, yeah, 12 is present. So we'll take remaining sub as the input. Now again, remaining sub as the input is there. You can see this is basically a true. We are taking remaining sub as the input. Now when we call this, you can see here, this will be my first sub and this will be my remaining sub here. Now
Yes.
12 is not present in the remaining sub, so that will return a false. Now if this return false, we have to go to else statement and we need to execute this one. This is basically what the first element plus plus remaining element. So we are merging the remaining two elements here. That's it.
Okay, sir, got
Okay.
it. Thank you very much, sir.
Okay, Saikat, is this clear now?
Yes, sir. Can we
Saikat?
go to third and fourth question?
So can you take my doubt? One, it is a small doubt actually.
Related to this concept only or what?
No, no, sir, it is 1 minute.
Yeah, so till then we'll discuss the
sir,
third
my
question, okay?
sir, my
So
doubt
I
in the
have no
previous question
problem.
was what
Yeah.
in the previous question we were discussing, sir. So,
Uh,
one for the first time when it was the 20th roll number in the list, then
uh,
where do we keep that the line of code? Because it is going to mm, uh, go to the next line and is skipping the roll number 20, and then it will be taking all the further iterations. So meanwhile, this 20 roll number line is going to store where? It is going to be back in the list or at the bottom of the list or what? Like
no,
we
no. So
discussed, it
we
will
are,
skip this line.
uh, yeah. So we are not removing it anywhere, right? So in the input only you can see rest sub is there. So we are skipping one element in the every call of this particular function here, right?
Mm-hmm.
So if you
So
look at
first
this
it
one,
will be
so
checking for the roll number 20.
uh,
Sorry, for 12, all the remaining
12.
uh, ones, and then it will go back to see the roll number 20. And
Yes,
then
yes,
we'll find out the combinations of 20. Okay.
yes, in the remaining list, right? So we are not storing it anywhere. We are simply removing that in the next call of this particular function. We are taking rest sub as an input here, right? So we are removing that one element. You can see rest of L, right? So we are removing one element from the list and we are taking that as the input here.
Yeah, yeah, I get it, sir, from this
Yeah,
particular line. Okay.
yeah.
Sir,
Okay,
my
great.
question is based on list only, sir.
Okay, what is your doubt?
Sir, I posted in the chat window.
Okay. Okay, yeah. Now, okay. Just a second. Let me download that. Yeah, so based on the out list, right? This
Yes,
question?
yes, sir.
Yeah, let me share that screen. Yeah, is this visible?
Sir, yet not. Yes, sir, visible. Sir, my
Okay.
doubt is third option I am getting correct actually.
Yes.
Third option, according to me, it is coming correct. I am not able to understand why third option is wrong.
Okay, just a second, we'll see. Yeah, so the why third option is wrong.
Wrong, yes.
Okay, so each element in out list correspond to one sentence from the paragraph. So out list is basically where. So first we are out list is basically IMT. Okay, then we are calling the rows. We are reading if start. So anyway, start is basically true. So in list is empty. Start false. Part of speech here. We are in list. Out list is here. Okay. Now outlist equals to outlist plus inlist here, right? So outlist is initially empty plus inlist. Now what is inlist here? You can see if part of speech is not adjective, we are going to store the word and its corresponding part of speech in the inlist here. Okay. So that will be the like this. Let's say for example, we have Monday and noun. Okay. Monday comma noun will get stored in the in list, right? For every word you can see here. Now, at the end of the sentence here, if you look at it was Monday morning, right? So we have that first sentence. Now after morning, let's say in the in list, we have this Monday comma noun, and then we are going to store out in the out list. So that will be a what? So this is basically a list, right? So you can see list. Now that in list is placed inside one more square bracket you can see here, right?
Yes, sir.
So Monday, comma, noun. So that is basically a list of lists. In the output, it will be Monday, comma, noun, then whatever the element we have, okay? Like that will be the element. So this is basically a list of the list here. So this is correct. Each element in out list correspond to one sentence from the paragraph. Each element in the out list, right? So here we have no. So in list will be a what? No, we cannot say like that, okay? Because here we are checking for this condition. Let's say, for example, any word is uh, not adjective, okay? Not adjective we are discussing. So here it will, Monday is true. Yeah. If any word is adjective here, so part of speech adjective not equals to adjective, this is basically false. So in that case, that word will not be in the in list, right? So any statement having adjective, we cannot say this will be true for that particular statement here. If any
But,
sentence having adjective here, right?
but sir, it is saying corresponds to means like first element of list is the list which correspond to the first sentence, and the second element will be the second list which corresponds to the second sentence. That is how I'm interpreting.
No, no. So here
But
each element
outlist
in the
will be
out
storing
list.
all the sentences, right? Sir, here
Yep.
outlist will be storing all the list of the sentences, right? In lists of
Yes.
all, not just the one sentence.
One sentence. Yeah. That is also correct. Yeah.
No,
In
sir,
out list, we are going to store all the
but
sentences. Yes.
each element corresponds to one sentence, sir.
Yeah.
He's saying.
Yeah. So each element correspond to the word and part of speech. If that part of speech is not adjective, then only we can say one sentence here. Okay. If that sentence consists adjective, then we cannot say it entire sentence, right? Correspond to one sentence from the paragraph. No. If I say length of out list, basically number of sentences in the paragraph, then we can say, okay. But again, providing that any what you can say, sentence consists of not like if any sentence consists of all the adjective, in that case that will be not there. But anyway, that sentence will not form. Okay. So this is
So
anyway not correct. Each element in the out list correspond to one sentence.
means the
Yes.
first element in the outlist correspond to first sentence, second element in the outlist correspond to second sentence, like that. Third correspond to third sentence. That is how I'm seeing it.
No. So that is not the case here. So mm, no. No, here we are not storing for the part of speech adjective. So in that case, we cannot consider
But
as
sir,
that.
it is saying corresponds to means just like it first list is coming from first element of the out list is coming from the first sentence. Second element is coming from the second sentence. I think corresponds to means that. So with the
One sentence from the paragraph. No. Okay. From which term this question was there?
sir, April 2025.
April 25. Okay.
It's,
No, correspond to one sentence from the paragraph. So element in that list we can put. Okay, we'll see. But here, based on this condition, we are only storing the word and part of speech if that word is not an adjective here. Okay, that's the only case. Okay, I will check with the team what we can infer. But here, we are not saying that all the words list
okay,
here.
sir.
That's
Okay,
why
sir.
this option may not be correct. Yeah. Any other doubt? Anyone?
Sir, I have doubts on the same paper, sir. Actually, 2, 3.
Okay. Can you share your question?
Yes, sir. I'm sharing.
Yes. Yeah, if anyone is having any doubt, you can ask now. That's it from my side.
So the question 4 and 5, sorry, 3 and 4 actually,
Okay.
from what you were solving, the graded assignment dilemma.
3 and 4.
Yeah, sir, in 3 it should be descending order, right, instead of ascending order.
What does the variable submission represent? Uh, list of also made by Huron of order in ascending order of the time. So you can see what is this ascending order of the time only, na? This one. What's the correct option given here?
Ascending order.
Yeah, ascending
So
order of time
yes,
only,
it
na?
will be
There is,
storing the ascending order since it is reversing the gets ups procedure for this part.
yes,
Uh,
ascending order is
So,
correct only, na? You can see the output.
okay, so we are considering the first, that is rule 12 as the like first entry.
Hmm.
Time, it is considering the time, right?
2350,
Yeah,
2353. So ascending
Time
order
and
you can,
ascending order.
uh, yeah, ascending order of time here we are discussing. Yep.
okay, so I got the point.
Okay.
And the fourth
Okay,
one.
so try to solve all GA and PA. Fourth question also. Okay, let me check. Reverse, assume that reverse proceed that reverse the list. Which of the following statement of the list of the first submission made by students already ascending order of the time? So the following statement returns the okay ascending order of the time. First submission made by the ascending order of the time. So here what we are
Yeah,
doing, we are getting
yeah, so I think it will be the last option. I was getting confused in the third, which automatically resulted the fourth being wrong.
first submission made by the student, right? So in the output we want So submission made by a student ascending order. So this will be like this, okay? So 10, 20. So we are reversing this list and then we are taking this. If we reverse, so this will go here, this will go here in the order. So 12.
The
And then
reverse
again
of
we have
reverse
to,
will be the same thing.
yeah, reverse,
Of
get
reverse.
sub reverse. So reverse goes, then again we are taking this as an input. We are going to get the last two element as the output. Then again we are going to reverse. Okay. So again, no, here we are taking the reverse as a input. So in that case, we'll take that one the output. Yeah. Which one is correct? C or D?
D, sir,
The
D.
D is correct here.
D,
Uh,
na? D is correct here. Okay. Okay. So that's it. Yes, Anurag, did you share the question?
Yes, sir, I've shared.
Okay. Yeah. So here we have this one. Yes. What is your doubt in this question?
So 1 minute. Yes, sir, my doubt is the question, that option which is marked as wrong, I am get like it is correct, appearing correct to me, sir. Actually, I have thought of, but I could not get.
Option number B.
B, yes, sir.
Okay. So here, 4 to 9 statement will be replaced by the above result here. Right. So this is what we have. We provide the correct
Sir, I have
Store's
sent,
dictionary with author's name as key. Yes.
sir, I sent
Number
second
of
image
books written.
also, which contains the complete second image also.
Yes. Yes, I'm looking that also. So 4 to 9, if we replace this one, it will give us the correct code. So see in here we are checking if not is key. Okay. So 4 to 9, if we replace, let me write it down. So here 4 to 9, right? If
Yes.
we replace this with if not is key, same thing is there, but the difference is author, x dot author equals to 1, and then we are adding that. Okay. So we want number of books written by that author, right? Like that. What happened?
Yes.
Okay. So here, yeah. So let's say, for example, if author is not in that dictionary, okay. In that case, what will happen? Author is a no, right? So not of will be a false, right?
Yes.
So in that case, what we are doing here? In that case, we will not execute the if statement. Just look at the option number B, right? If that author is not a part of the dictionary, so that will be a false. So not of false will be a what equals to true. Okay, so we are saying it is equals to 1. Then again, we are going for line number 4. So again, we are incrementing the value of author by 1, right? So for the
Yes.
only one iteration of author, we are incrementing the value of author 2
No,
times
no,
here. This is
sir.
what we are doing.
Sir, I am talking about like option number 2.
Yes, yes. Okay. Option number 2 only. Let me share that image. So you can see here this one, right?
Yes.
So here, let's say for example, any author A, B, C is not in the list. Okay. So here in not list means dictionary, we don't have not in the dictionary. So is key will be a false, right? Because
Yes.
author is not present in the dictionary. So not a false will become true. So in the dictionary, we
Yes.
are going to add the author name and the corresponding value will be a 1. This is fine. Okay.
Yes.
But after this, we are going for line number 4 also. Na? Again, we are calling the dictionary. We are taking for that author. And we are including the value of author by 1. So here 2. For only first row, we are incrementing the value of ABC by 2. This is not correct. Na? It should be 1
No,
only, right?
sir, this fourth line is for else statement, na?
No,
Fourth
no. Here
line.
we have replaced line 4 to 9 with the below code here. We
Yes,
don't
sir.
have any else block here, right? We don't have any else block here in this, if you see. Only if statement is there. That's it. Okay. We don't have else block here.
The fourth statement will be if author is not present in the key as a key in
Mhm.
dictionary A, then also fourth statement will be implemented.
Yes, it will execute every time because it's not a part of any if statement here.
If else was
Okay.
there, then it would no, it wouldn't have been executed.
Yeah, if else was there here, else, and then we have this inside else block, then it will not get executed. Okay, then that will be a correct. Okay.
Sir, sometimes I have seen that else is not written, but it is inferred as else. In
No,
many
no.
in
So
some questions I have seen else is not written, but it is they infer it as else only. How is that, sir?
no, no, no. Can you share those questions like that? So see, we have if else statement. Okay, if condition is true, then only we are going to execute this one. Otherwise, we go to else block here like that. But
Okay.
if else statement is not present, we only check the if condition, then we'll proceed with the next block here. Okay. If condition is false, we are not going to do anything here. We'll simply go for a next line of code like that.
Okay. Yes.
Okay.
Sir, I have one more question, sir. Last question, sir. Can I share that?
Okay. Okay. Yeah. So this
So
will be
1
the
minute.
last question. Yes. Yeah. So just focus on PHEA and previous term question, and you can watch the previous session. We have discussed everything from last 4 5 sessions. This is good enough for end term exam. Okay.
Okay, sir. Thank you. So I'm sharing.
Yeah. Yeah. Please.
So I get a lot of buzzard and questions whether like we have to put a code and like pseudocode. The options are given and the like options seem a little bit similar. Those kind of questions. So can you suggest me anything to avoid confusion?
No, go with option wise only. Okay, in that particular case.
Yeah, like
So
some options seem similar and it feels like this can also be the answer, but this can also be the answer.
yeah, okay. So first, read the question, like understand the requirement here. There can be some few corner cases that will not get satisfied by that particular option. Okay, you have to think in that manner. What will happen? Okay, if list is empty or dictionary we don't have that particular key, or if you see what will happen if the list will consider that particular value. In that case, will this option work? Like that, you have to see. Okay, so there are a few corner cases. You have to check for those cases in that particular manner. It may look that
Okay,
both
sir.
options are correct, but one of the options may not satisfy for one corner case, right? What will happen if the list consists duplicate value? In that case, that option will not be a correct. Okay. So you have to check for those.
Okay, sir.
Yes, Anura, can you share that question?
Yes, sir. I'm just sharing, sir. Actually, it has 4 images actually.
Okay. Which paper?
Sir, it is April 2025 end term paper, sir.
April 25.
Yes, sir.
April 25. Okay. Which question?
Sir, sir, that 1 minute.
Just
Sir,
yeah.
it is, sir, question number will may be different, sir.
Yeah. It is a NAT MSQ compression type.
Sir, it is
And
shop. It is shop name and like shopping bill data set. It is based on shopping bills data set.
okay,
It will
I'm
be better
sharing my
if you
screen.
share the link of the particular question paper.
Yeah. Can you see my screen? Is this a question?
So 1 minute. Or let me. So can you scroll down, sir?
There's
Yes,
only
sir.
one
This is
question based on shopping bills.
yes,
Yeah.
yes, sir. This is the question, sir.
Okay.
Actually,
What is
sir,
your doubt?
sir, I could not dig deeper into the question because I thought for about the question, then I got the headache. Actually,
So based on the shopping bills data set, here we have two dictionary, item D and cost D. So here we have while loop, while file one has more cards. So if you look at the shopping bills, we have the category, we have item list, we have shop name and the sequence number and the customer name, right? All these details we have. We are going to read the top card from file one, item D equals to update that particular item dx. So we are going to call the procedure here and the input will be what? Item D, that is basically initially empty, and that particular card here. So what we are going to do? Okay, any doubt in while loop here?
sir, please
While
repeat.
loop is fine.
Please repeat this.
Yeah,
Your
any
line of thinking, sir. Actually,
yeah. So what we are doing here, we are reading the first card from the shopping bills, right? We are
yes, sir.
storing the output of this function in item D here. So we are calling the update dictionary here at this line number 4. So we'll refer to this procedure with empty dictionary and the X as what card here. X is basically that row and item D is basically dictionary here. So we need
Yes,
to update that dictionary. So what we are checking if shop name is present in that dictionary or not. If shop name is present, so output will be a true, but not of true will become false here. Okay. If shop name is not present because initially dictionary is empty here for the first card. So anyway shop name is not present. In that case, this will become false. Now not of false will become true, right?
yes, sir.
And what we are doing, we are creating a key for that particular shop name. Now let's say for example, we have a card for a shop name Big Bazaar. First card we have drawn and the shop name is Big Bazaar. But dictionary is empty initially for the first iteration. So Big Bazaar is not present. That is false. Not of false will be true. So what we are doing here in that item dictionary, we are going to create a one key Big Bazaar and the corresponding value will be a dictionary here like that. You can see.
Empty dictionary.
Okay. Empty dictionary. Now what we are doing for each A in item list, for every item in that particular item list, what we are checking whether that item is part of this one. Now what is this? Yes, tell me what is D of shop name?
D of shop name is empty dictionary.
Yeah. So this is basically empty dictionary we have initially. So whether item is present in that dictionary is key. No, initially it is
No.
not present. So we go to else block. And what we are doing here?
So,
We are adding the cost of the item list in the shop name. Shop name
Yeah.
and then item and the cost.
So here D shop name, that is Big Bazaar here. So we are referring to this dictionary. Then we are creating one more key here, that is item. So this will be like this Big Bazaar, an empty dictionary that will be.
Sir, why it is
Yes.
saying A dot item? What
So
is it?
here
Capital
we
A?
are for
Acha, for each.
every item in that item list.
Okay,
Okay.
sir.
If you refer to a data set, we have a different item list here, 1, 2, 3, like that. So
Yes,
we
sir.
are going one by one here. Okay. For every item in that item list, we are creating a one key. Let's say, for example, we have milk. Okay. And the cost of that will be the corresponding value. Let's say, for example, 20 here, like that.
Okay, sir.
Okay. So we'll go for a next item. Again, next item is, let's say, for example, pen. So again, we are going to add pen and the corresponding value here like that. Okay. So this is for when shop name is not present. If shop name is present, let's say, for example, we go for a next card, and next card is also Big Bazaar. In that case, what will happen? Shop name is a key. Yes, already present. So we're not going to create empty dictionary. We simply go for each loop. Again, we'll go for an entire loop here. We'll check whether the item is present in that dictionary or not. Let's say, for example, in the card 1, we just have two items. Milk, that is 20 rupees. Pen, that is 20 rupees. Now we go for a next card for the same shop. Again, here we have, let's say, for example, chair, 20 rupees, and pen, 30 rupees. Now in that case, what will happen? See, when item is equals to chair, just tell me what will happen here for loop, because anyway, this is not satisfied. We are dealing with the same shop here.
Sir, here else statement is not there, no? In if
No.
block.
No, if this statement is true, we are going to execute this one. If this statement is false, we'll go for a else block here.
Sir,
Else you can see.
Okay, no. So I'm talking about 23rd line number 23.
Yeah, here we don't have a else block here.
So even if
Only
the if line number 23 is true, then also for loop will be executed, no?
Yes, this is independent of this if statement here. For
Okay,
loop
sir.
is outside. You can see,
Okay.
right?
Okay.
So when the next item is chair, so we are going to check whether chair is in the dictionary or not. If not, it will go for else statement. We are going to add chair as well. That is again 20. Now what will happen if I go for a next element, that is basically pen? Now what about this condition? Is pen is a part of a dictionary?
Yes, sir.
Now here you can see already pen present. Yes. Now we are going to execute this one. So shop name Big Bazaar, item is pen. Here we are going to take the value of that plus the current value of pen, that is 30. So output will be 50. So we are going to update that into the dictionary here. Right?
Yes, sir.
So what we are doing here, we are creating a dictionary. The key will be a shop name, and in that corresponding value will be again dictionary. In that key will be the item list, and the corresponding value will be a summation of all the cost here, like the cost of uh, all the items purchased for that particular item, we can say, or the summation of cost for this particular item, we can say, paying for example 50, like that. Okay, this is how this code will work.
And
Now
sir,
if you look at
no, sir,
yeah,
and
yes.
this second one from line number 8 to 19, another one is
Yeah,
there,
okay.
no?
Yeah. So we are going to create that dictionary first for that particular card here, like that. And we are doing this for all the cards. Now, once we have done for all the cards, item D will consist of what? A shop name, then corresponding value will be the items, and the value will be what? Total price of that particular item. Total price means revenue for that particular item, we can say, right? So pen is
Yes,
50, for example, like that. This for every shop name, Big Bazaar, Sun General, like that. Now what we are doing, we are taking that entire dictionary as an input here. So till we are not going for line number 8, we are in the while loop only till we complete for all the cards here. Once we complete all the cards, once we create entire dictionary here, we are going for a loop, for loop for I in keys of item D. So here keys will be what? Yes.
So the shop name.
Yeah. So list of shop name, that is Big Bazaar, Sun General, like that, right? So what we are doing here, for every shop name, keys of item of D. So item D. So basically what we are doing, shop name is Big Bazaar. So here will be what? This dictionary. Output is this dictionary. So keys of this dictionary, what? What this will give us? Tell me. So item is I. I is basically Big Bazaar. No, what is this? Item of BB. What is item of BB here?
So it is keys in item of BB. Okay.
Yeah. So what is this item of here? That is basically this dictionary, right?
Yes, sir.
Dictionary consists of the item with the corresponding total revenue. Now, and keys will be what? List of item from Big Bazaar.
Sir, item D, item, 1 minute, item D. What is item D? Item D is that bigger dictionary or like
The item D
corresponding?
is dictionary. No. Here we updated dictionary here, right? So bigger dictionary, what we have created after going through entire while loop. That is what item D
Okay.
here. So in
Okay.
item D, we have all the shop names, corresponding value will be the dictionary having the item list and the total revenue of that particular item here, like that.
Okay.
So what we are doing here, item DI, and I is initially Big Bazaar. So we are going for this item dictionary, Big Bazaar. Output will be again a dictionary here.
Okay, sir.
Okay. So dictionary, in that case, value will be item and the corresponding revenue. So keys will be what? List of that keys. That is basically a list of items,
Yes.
right? And now we are applying for each group. For every item in that particular list, what we are doing? Item D, Big Bazaar, and that particular item. So let's say, for example, milk equals to B. That is value of B is 0 here. So we are trying to compare the cost of milk, that is basically 20 here, right? So 20 equals to 0? No. We'll go here. 20 greater than 0? Yes. So we are going to update the value B to a 20 here. An item will be that particular item J. So here we are discussing about the milk. So that will be a milk here. Then we go for next iteration. Next item is basically pen. Now we compare the value of pen here. Now I is Big Bazaar only. J is basically a pen. Value of Big Bazaar pen is basically 50. 50 equals to 20. No, not correct. Go for this if statement. Again, 50 greater than a 20. Yes. So we are going to update the value of B to 50 here. And then item J to update to pen here. So what we are doing here, yes, tell me what we are doing here if you understand this one. What B will store, what items will store.
Sir, list of all the items of that
Yeah,
particular.
items. Yeah, so what's the value of B here? First I compare with the milk, so we got 20. Then if I go for a next item, then we got 50. If I again go for a next item, that is chair, but anyway 20 is not greater than 50, so it will not get execute. So what B is storing? B is 50, but what is 50 here? You can see
So, the
highest value of that in that particular dictionary, we can say, right? That is 50 among all this. We are comparing with every item here, right? You can see we are comparing with every item. So B will store the value of that particular item, and items will store the list of that item which is having the highest revenue. You can see pen, for example.
revenue
Okay.
or cost, sir? I'm
Yeah,
confused.
total cost or revenue, we can say. So
But cost option is
revenue
also
only,
there.
na? No,
Okay, okay,
cost will
revenue.
be revenue because we are summing up for all the same items here, you can see,
Okay,
right?
okay.
Yeah. So option will be what you can see. So item D, IJ. So item D is dictionary. I is basically a shop name. J is basically that item name. So this will represent what? The cost here. So revenue generated by this particular item pen for the shop Big Bazaar. That is what option A is, right? So like that you have to do.
Sir, it is difficult, sir, actually.
Yeah, this
Like,
question is difficult.
yes, sir, how to
Okay,
think,
so try to practice.
sir,
Huh?
how to think about like these questions, like, because it gets very confusing doing solving.
Yeah, so you have to do practice only here, right? So there is no shortcut. Try to solve more questions. So best way is just solve all the PA, all the GA, and whatever the previous term questions you can see. Okay. So just practice. This is more than enough. Okay.
So can you pinpoint some questions like like from PYQ, like which to solve, because
No,
time is not.
every no, every week has a equal importance here, right? Because whatever we are discussing here also discuss the concept of dictionary and list. So
Yes, sir.
this course is like that. Every question, every week, it depends upon the previous week only. Okay, like that. Okay. So that's it from my side. All the
Thank you,
best
sir.
for the interim exam. Yeah.
Thank you, sir.
Thank you. Bye bye.
Thank
Good night.
Thank you, sir.